All right. So an altitude of a triangle is the perpendicular segment from a vertex to the opposite side or to the line that contains the opposite side. So look at the triangle on the left. The triangle on the left has an altitude that goes from Q and is perpendicular to PR, right? So that's what it means by when it says perpendicular to the segment. In the triangle on the right, the altitude is actually outside of the triangle, and that's where you get the idea of where it says from the vertex to the line containing the opposite side. So sometimes our altitude is going to be outside of our triangle. If you can recall back in middle school, when you learn how to find the height of a triangle, or when you have to use the height of a triangle to find your area, and sometimes the height would be outside of the triangle, this is the same thing. Okay, so your altitude can sometimes be outside of the triangle on the line containing the side, and that's what you have in the image that's on the right. So then the lines containing the altitude of a triangle are concurrent. So of course that means there's 3 altitudes in a triangle. They are concurrent. Their point of concurrency is the orthocenter. So now we've got circumcenter for perpendicular bisectors, incenter for angle bisectors, centroid for medians, and now the orthocenter for altitudes. Okay, so in this particular picture, the lines containing AC, BD, and CE meet at the orthocenter G. So in this picture in the top right corner, G is the orthocenter. And then the location of the orthocenter depends on the type of triangle. If it's an acute triangle, then the orthocenter is inside of the triangle, just like the circumcenter. If it's a right triangle, the orthocenter is on the triangle, just like the circumcenter. And if it is an obtuse triangle, then the orthocenter is outside of the triangle. So same as the circumcenter, okay? It's either going to be inside, on, or outside of the triangle. Any questions about where the orthocenter is? Okay. So pretty straightforward. So now we just need to find the orthocenter. Okay, so it says find the coordinates of the orthocenter of triangle XYZ, and it gives us the vertices. So I'm going to take a little bit of time to draw the triangle. Glad I got some lines to help me out. All right. So I need -5, -1. It's going to be my X, and -2, 4. That's going to be my Y, and then 3, -1. That's going to be my Z. So based on this triangle, is my orthocenter going to be inside, on, or outside of the triangle? Inside, right? So because this is an acute triangle. So if we don't get an orthocenter that's on the inside, then we've done something wrong. Okay. So now, by definition, the orthocenter is the point of concurrency of the altitudes, and the altitudes go from a vertex perpendicular to the other side, right? So in order to know if a line is going to be perpendicular, then that means we have to know the slope of that line, right? Which one or where do we want to start that's going to be the easiest for us? If we need to find a line that is perpendicular. Where should we start? What do y'all think? If we need to find a line that is perpendicular. Huh? No. Not finding the altitude. We are finding the altitude, but the altitude is a line that is, the altitude is a line that's perpendicular, right? Okay, so when we talk about things being perpendicular, that automatically means that we have to look at slopes. So if I need to find a perpendicular line, where should I start in this particular triangle to find a perpendicular line? Because remember, you want to really realistically do the least amount of work possible. You do whatever's going to be easiest. So which perpendicular line should I find first? XZ. XZ is a horizontal line, so the perpendicular line has to be vertical. Just that simple. Don't make it harder than it is. So the altitude 2xz has to come from y, right? And it just has to be a straight line because xz is already horizontal. So I'm just gonna draw a straight line. That's gonna be right here. Boom. Actually, let me do it in a different color so we know and we don't get confused. So what point is this here? This is -2, -1. Okay. All right. So we have one altitude already. So we just need to get one more so that we can find the perpendicular line. So do we want to get the line that goes from z to xy, or do we want to get the line that goes from x to yz? It honestly does not matter. So let's find the slopes and see which ones we may prefer to work with. So first, let's find the slope of xy. The slope of xy. So that's going to be 4 minus -1 over -2 minus a -5. So 4 minus -1 is 5. -2 plus 5 is 3. So the slope of xy is 5/3. So that will tell us where the line from z to xy would be. Now let's find the slope of yz. So that's going to be -1 minus 4 over 3 minus -2. So -1 minus 4 is -5. And 3 minus a -2 is a +5. So that slope equals -1. I think I like the slope of yz better than I like the slope of xy, right? Because we definitely want to work with -1, right? As opposed to 5/3. So the slope of yz, let's switch it up a little bit. The slope of yz, ooh, that's bad. This slope is -1, right? So the line that is perpendicular has to be what? The opposite of -1 is 1. The reciprocal of -1 is, or the reciprocal of 1 is 1. So we need a line that is perpendicular, would have a slope of 1. And it needs to come from x, which is -5, -1. So now we have to come up with an equation for this line. A line that has a slope of 1 and passes through -5, -1, right? So I'm just going to put it into my point slope form. Y minus a -1 is equal to m, which we know is 1, times x minus minus x1. So that's going to be y plus 1 is equal to x plus 5. So then y is equal to x plus 4. Do we agree? X plus 4 has a y-intercept at 4, and it has to go through this point here. So my line is going to be here. Boom. So that's my line for the altitude. And we're almost done. Now we need to know what the point is where the red line and the green line intersect, because that's going to be our orthocenter. Okay, so the red line is a vertical line, and a vertical line that is at, get red, x equals -2. So that's this vertical line. So this line is x equals -2. And we need to know where that intersects with y equals x plus 4. So we need to know the intersection of these two things. Well, that's really easy. All we need to do is put x into y. So we end up with y equals -2 plus 4. And so -2 plus 4 is 2. So y is equal to 2. So then the intersection has to be at when x is -2 and y is 2. And that's going to be right here. That's -2, 2. And that is my orthocenter. Questions? So really, these are our algebra skills applied to a geometry concept. So you have to make sure you understand the concept in order to use your skills to find the actual value. All right. Does everybody have this before I delete it? All right. So your last slide is just a recap of the new vocabulary that you have. So perpendicular bisector, circumcenter, angle bisector, incenter, median, centroid, altitude, orthocenter, and then some properties that apply to your points of concurrency. So the circumcenter is equidistant from the vertices, the incenter is equidistant from the side, the centroid is two-thirds of the length of the median, and then orthocenter doesn't really have anything special about its properties. Questions, questions, questions. All right.